Good evening. My name is Aiden Houston, and I will be illustrating the Solow model showing how an increase in the depreciation rate will change the production function in steady state. So first, we're going to draw the graph. I'm going to have both our vertical and horizontal axis, with our vertical axis being y, which represents the output per worker, and the horizontal axis being k, representing capital per worker. And then from here, we're going to draw our production function. And let's add our savings line. It's going to be savings. Our production function. And we're going to draw next the line that will show us how much of the capital is needed to keep the capital per worker constant. And this is going to be labeled see. There we go. Just like that. And we're going to show the steady state now. Which is going to be represented right here. We're going to label it steady state A. Let's show the corresponding level of the capital per worker. And what would be the output per worker in steady state A. And now what we're going to do is simulate the change in depreciation. We're going to show an increase in the depreciation rate. So let's assume depreciation rate will increase and we will increase from D2, we will label it D prime. Alright. And now we will need to graph it. It's going to be a rotation upward, and we're going to represent it with this blue line. And this will correspond to a higher depreciation rate, being D prime. Which will create a new steady state. We'll label this. D prime. There we go. And this will create a new steady state of B, where it intersects with the savings curve. So we are going to show this right here. We'll represent this with B, and we'll show its correspondence with both the capital per worker and the output per worker, being Y. We're going to represent this by K prime and Y prime. And now we're going to explain the logic of this transition. And we're going to start at the original steady state of A. Where there's an increase in depreciation rate. that a savings are higher than it is needed to keep capital per worker constant. It's greater than and the result of the savings being higher will result in change of the capital per worker. But this will be negative. Change the capital being negative. I need to fix this one. This is going to be 2, 2. Okay, 1, and y1. The capital per worker decreases and the economy moves to the left. Which is why we have to decrease the capital until it comes to the new steady state of B. When the depreciation rate increases, more capital is getting worn out for each, or lost for each period, and the economy needs more capital to keep up. And if the savings rate being represented here, in this case representing savings and investments, it stays the same, and it can't replace the extra capital lost due to the higher depreciation rate and the increase in depreciation. And in the new steady state B, the economy will eventually adjust to its new rate, but at a lower capital per worker, and output per worker, because it is lower than what is before. Higher depreciation means more capital is lost, and when the depreciation rate increases, the more capital worn out each period does as well. So the economy has to replace more capital just to keep the same amount of capital per worker, which will result in B, where y1 is greater than y2, and the capital per worker is greater in 1 than it is and b at the new steady state of capital 2.